Hello students, this is Sir Murtaza and welcome you to another lecture of physics. So let's start. So in this lecture, we will first talk about our agenda. So we are going to discuss the following SLOs, and the SLOs are derived expressions for the tension and acceleration in a string during motion of a bodies connected by a string and passing over a frictionless pulley. So it means that in this lecture video, we will be talking about tension, we will be talking about acceleration, uh, where in a string during motion of body is connected by a string and passing over a frictionless pulley. Okay, so what is it? Let's look on a little more further. So first we will talk about tension in string. Okay, so here the word string, before telling its definition, string आप कह सकते हैं कोई भी चीज़ जिससे आप किसी को सस्पेंड कर दें. फॉर एग्ज़ाम्पल अगर आप रस्सी की बात करें सो रस्सी इज़ कंसीडर्ड एज अ स्ट्रिंग. अगर आप धागे की बात करें वो भी स्ट्रिंग कंसीडर किया जाता है. और इसी तरह से अगर आप चेन की बात भी करें, यानी हर वो चीज़ जिसके साथ आप किसी भी ऑब्जेक्ट को सस्पेंड कर सकते हैं उसको हम कहते हैं स्ट्रिंग. उसके अंदर हमने टेंशन फाइंड करना है. सही है, तो अब हमें पता ये होना चाहिए कि व्हाट एक्चुअली इज़ टेंशन इन स्ट्रिंग. So the definition is the upward force or the pulling force acting on a body when it is suspended by it. Okay, now what does this mean? Now for example here it is a string. Okay, consider that this red line is a string and we have suspended an object with the help of this string. Now in order to suspend this we need an upward force. Okay, why? Because the weight of the object is acting downward. Now in order to make it stable or in order to make it at rest, we need to put an upward force. Okay, so actually the upward force or the pulling force is known as the tension in string. Okay, it is very simple. Now for example, if you just suppose that you are lifting for example a book. Okay, so in order to hold that book, what force is required? Whatever the weight of that register is, you have to apply that force in order to hold it. Okay, and that force should be in the upward direction. So here is the same thing. Tension in string, tension is always acting in the upward direction if the weight is acting in the downward direction, and it is the upward force or the pulling force. Okay, now there is little explanation. In this explanation, what we are doing, consider a block supported by a string. The upper end of the string is fixed on a stand as shown in figure. Okay, let W be the weight of the block. The block pulls the string downwards by its weight. This causes a tension T in the string. The tension T in the string is acting upwards at the block. Very simple. We have considered a block which is supported by a string as shown in the previous diagram. The upper end of the string is fixed on a stand as shown in figure. Okay, you can see that the upper end of the string is fixed. Now W be the weight of the block. Definitely the block pulls the string downwards by its weight. Now if we have suspended an object with the help of the string, so the weight of the object will pull the string downward. Okay, now this causes a tension in the string which is in the opposite direction. Okay, so this is a tension in the string which is acting upward at the block, or you could say in the opposite direction. Now as the block is at rest, therefore the weight of the block acting downwards must be balanced by the upward tension T in the string. Now there is one thing, if the block is at rest, it means that the net force should be equal to 0. What happens is the tension is acting in the upward direction. This is the tension, and the weight is acting in the downward direction. So in order to make it or you could say in order to make it at rest, the net force should be equal to 0. It means that T minus W should be equal to 0. This will show that the body is at rest. Okay, this is one condition for it. Thus the tension T in the string must be equal and opposite to the weight W of the block. Okay, so this is about the tension in the string. The tension is always acting in the opposite direction. Okay, and this force is the pulling force. Now we have a case when both the bodies are hanging vertically. There is a case in tension in string that we have two bodies A and B and both the bodies are hanging vertically. Now let's look on to the explanation. Here we consider two bodies A and B of masses m1 and m2 respectively. Let m1 is greater than m2. Now what we have done, we have taken two bodies A and B. The mass of body A is m1 and the mass of body B is m2. And one more thing we have said, that m1 is greater than m2. m1 is greater than m2. Now what happens is, the bodies are attached to the ends of an inextensible string such that both the bodies are hanging vertically. The string passes over a frictionless pulley as shown in figure. Now what happens is, these two bodies are attached with the ends of a string. You can see this purple line is a string, okay, and both these bodies are attached with a single string but to the ends of it, okay, and it is inextensible string and it passes over a frictionless pulley. This part is the pulley. Okay, so this is the explanation. Here we have two bodies A and B, and both the bodies are hanging vertically. Okay, now what happens is, we will talk about it one by one. Now for body A, as the mass of body A is greater than the mass of body B, so body A moves in downward direction with some acceleration. Now it is obvious that if the mass of body A is greater than the mass of body B, so body A will move in downward direction with some acceleration. Okay, now according to Newton's second law, the force which is responsible to produce acceleration is equal to, okay, we have learned previously that if body is producing acceleration, it means that some force is acting on it. Okay, now according to Newton's second law, the force which is responsible to produce acceleration is equal to what? It is equal to F is equal to W minus T. Now why we have subtracted weight with tension? Because the weight of the object is greater than the tension. Okay, as the body is moving downward, so we can say that weight is of greater magnitude and T is of smaller magnitude. It means W is greater than T. We'll do some maths. F is equal to ma, so for first body we can replace m by m1, and W is equal to mg, so for body A we can replace m by m1. Okay, and the other remains the same, minus T. This we will name it as equation number 1. Now for body B, as the mass of body B is less than mass of body A, so body B moves in upward direction with some acceleration. Now for body B, as its mass is smaller, so body B will move in upward direction. Okay, now again according to Newton's second law, the force which is responsible to produce acceleration is equal to, now this time what we have done, W is equal to T minus W. Okay, this time we have subtracted T with W. Why? Because the value of T is greater than W. Why it is? Because as the body is moving in upward direction and the direction for tension is in upward direction, that is why T is greater than W. Then what we will do, we will replace F by ma, and for second body we will put m as m2 and W as m2g. The formula is mg, but for second body we will replace m by m2. Okay, and now we will name this as equation number 2. Now what is the is the purpose for this lecture? We have to derive the formula for acceleration and tension. So first we will talk about acceleration. The two equations that we have made will be used. Now for acceleration, what we have to do, we have to add equation number 1 and equation number 2. So this is equation 1 and this is equation 2. Simple maths, we will add the left hand side of the equation with the left hand side and the right hand side of the equation with the right hand side. Now what will happen? In the left hand side, m1a plus m2a is equal to m1a plus m2a. We can't add it, just we will write both these values in a similar way. And here we can say that minus T will be cancelled by plus T. What remains? m1g minus m2g. Then what we can do? We can take common a as common, and in the bracket what will be remaining? m1 plus m2, and here we can take we can take g as common. Okay, and what remains in the bracket? m1 minus m2 and g. Now we have to find the formula for a, so this will become, this value will come in the denominator, so the formula will become m1 minus m2g upon m1 plus m2. So this is the formula for the acceleration. Now we will talk about the tension. Okay, now for the tension, what we have to do, we have to divide equation 1 and equation 2. So left hand side will be divided by left hand side, right hand side with right hand side. A will be cancelled. Okay, then there will be cross multiplication. We will multiply this with the bracket. This will come, then we will bring this on this hand side and T on one side of the equation. Okay, then we will take T as common. Then we'll put this